So, we'll be starting with building AI system, a practical guide for software engineering, which will be handled by our first speaker, Ibrahim Lukman. And after that, we'll have the Q&A section, and it's going to be interactive. So next, we are going to have the spotlight, which is going to be from Alert Pay by Wema Bank, which is going to be handled by Adejoke. And next, we are going to have Q&A section, and it's still going to be interactive. And next, we are going to have interactive game section and a closing remark. And we'll equally like to get a feedback from you. So without wasting much of our time, we're going to start with the first speaker, who is to be Mr. Ibrahim Lukman. He is the CEO of Case Solutions, and he is an expert in this industry, and he has many years of experience. So we'll be hearing from him. Over to you, Mr. Ibrahim Lukman.
All right, so thank you, Chidi. Um,
Yeah, welcome.
start on my camera. All right, good morning, everyone, and glad to be here to share some insights with us on AI. So let me quickly just because I have this guy out before. Okay. Please let me know when you can see my screen.
Yes, we can see your screen, sir.
All right, so welcome to this session once again, everyone. My name is Kenny, and today we are going to be talking about building AI system, and of course, as it affects software engineers. So today I'm going to be talking to us as a software engineer myself, but also I'll be speaking from a research perspective, as I'm also a researcher. Um, of course, I'm also going to be talking to us from a user's perspective. I'm also a user of AI. I'm privileged to be part of the 42 Nigerians who are picked to lay the foundation for AI system in Nigeria. We are working with the Ministry of Communication under the Nigerian AI Artificial Intelligence Research Scheme. And what we are doing right there is, trying to create that community of AI system, and one that not only consumes AI that's being produced everywhere in the world, but the one that also produces AI. We've been working for um, almost 2 years now in a community, of course, in collaboration with people outside the show as well. So today I'm going to be sharing insights as, of course, like I mentioned, as a software engineer and also as a an academic researcher as well. I'm available on social media, even though I'm not a social media person like that. But you can find me there on Twitter. You can find Kenny at underscore IB on LinkedIn. You can look for something to come out. Just try to look for it; it will come out, and then you can follow me if you want, and then we can uh, to learn some of the things that I share from time to time when I have time. Okay, so today we are going to be talking about AI and software engineers. We are going to be talking about the development pipelines that is available to software engineers um, as they do deal with AI. And then we are going to be talking about AI models, how AI models are trained, and how AI models get fine tuned. And of course, the deployment strategies that it's available for the AI. So those are the parts that we're going to be exploring. I would want this session to be as interactive as possible. It's not going to be a radio kind of uh, session. So I'll be trying to bring us into conversation as much as possible, and I hope that we're going to be very responsive so that we can have that productive session together. So with that, we are going to dive in. The first question I'm going to ask, as I said, I'm going to be bringing us in as much as possible. Who is a software engineer? Who is a software engineer? So I want someone where majority of the people on this line are software engineers, almost everyone. So if someone can just tell us who he thinks a software engineer is, who is a software engineer? Let's start with that. Anyone, please. Who is a software engineer? I hope I'm audible.
Yes, we can hear you very well, sir.
Who is a software engineer? Yeah, Mr. Ajibade.
Yeah, good morning, everyone. Uh, from my own little knowledge, I'll say a software engineer is an individual that design and design or create applications for computer that can be used by end user uh, or by the computer itself to perform a particular task.
Thank you, Mr. Ajibade. Mr. Usman Sal, you want to add to that? Thank you. Go ahead, Mr. Usman.
Thank you. From my perspective, I think a software engineer is a professional that solves problem, right? So it could be with coding, with some other areas of technology. Yeah. So the main thing is just that this solves a particular problem.
Okay. Thank you very much, Mr. Usman. So I think that's the bit I'll take so that we can manage time. We have only a little over 1 hour to have this conversation. So I like the two perspectives and they put it together. Mr. Jibaya says software engineers write code, um, for computers. Mr. Usman says software engineers write code, solves problem, not necessarily through software or also, uh, technology, so to speak. So my take, and of course from academics perspective, I always try to distinguish between a software engineer and a software developer because they are not the same. Software engineers and software developer are two different individuals. One of the definition given is a software developer, the guys who has been given instruction and then who just write code based on the instruction that has been given, and then and that's right based on that requirement. A software engineer does something different. A software engineer applies what we call engineering principle together with software knowledge, that's the programming knowledge, to solve problem. Bottom line, problem solving. But then it also involves applying engineering principles. I'm going to put this up so you can see. Applies engineering principles. I try to underline engineering principle, and then knowledge is also very key, and knowledge of programming language to build software solutions for end user solutions, solving problem. Now, so when we talk about engineering principle, there's something that's a key that you also need to try to understand what it means to say you are, applying engineering principle. This has to do with first, not all problem are worth solving. You don't just jump on up and say there's a problem here, you start solving it. You are going to have to analyze that problem, the impacts of that problem, the economic viability of that problem, the sustainability of the solutions that you are building. So everything has to come into play optimization is key when it comes to engineering. I'm also, of course, I didn't say that. I'm also a trained engineer. Of course, not only, of course, as an engineer, I'm a trained engineer as well. So optimization is key when it comes to engineering. So when you just see a problem at the surface, you just don't jump on and start solving them. You have to do a whole lot of analysis before you decide to solve that problem. And then when you are solving the problem, there has to be alternatives. Alternative A, the way you can solve it. Alternative B, the way you can solve it. Alternative C, which one is the most optimized process, and all of that. You have to put that into play. Anyone who applies that principle in solving the problems, in software problems, is a software engineer. The guy who just write the code based on the instruction he's been given is not a software engineer, and he should not be called a software engineer. So we need to get that straight before we start this session at all. So now, moving on now, this session is about AI and a software engineer. AI and software engineer. So you can see this right here. You better be careful who you shake your hands with. Software engineers shaking hands with AI. They might just be here to take your job. So you better be careful. So I want to know how AI and software engineers fit in the same sentence. How they fit in the same sentence. AI and software engineer. How they fit in the same sentence. So I want to invite us. AI and software engineers, how do they fit in the same sentence? I want someone to talk about it. Hello, please. Can anybody tell us how AI and software work together? Mr. Usman.
All right, thank you. AI and software engineer can work together because as software engineers, so day-to-day activities can be or some, let me say, some routine tasks can actually be made simpler for you by leveraging on AI, and some other things you do that you don't need to like keep doing, like things you don't need to keep doing yourself. So you can just um, leverage on AI to like help you do that. While you can also use AI to learn, so to continue, because as a software engineer, so continuous learning is very important. So AI can help you like to learn vast like area of knowledge. Yeah, thank you.
Oh, okay, so we use it. Okay, somebody else, Mr. Chidi.
Yes, thank you. So, AI and software engineer both solves problem. They are problem solvers. So, and now it's a software engineer uses AI to solve a problem. I said earlier, AI solves problem, software engineer solves problem. But now a software engineer brings in AI to solve a problem faster and easier.
Okay.
So this is how both
Okay.
are linked.
All right. So that's about the input I will take so that we can manage time. I like both perspectives. I think we are saying the same thing. AI solves a problem, software engineer solves a problem, and then software engineer uses AI to solve a problem. So most of our episode 1 of this Productive You, episode 2 of this Productive You has been focused on using AI as a automation. We are talking about automations, either automating security in the development pipelines, or using automations for our DevOps, or using automations in development, so to speak. So, of course, we are using AI in that light as a productivity tool. The summary for that is that it's a productivity tool, whether it's automation, whether you're using it to learn, as Mr. Usman, to expand your own knowledge and all of those things. The bottom line is that you're a bit more productive when you use AI. So that's number one, but that's not all as a software engineer. That's not all as we use AI. You use it for automation, then what? than word. The second part is that as a software engineer, you're also responsible for building AI solutions, for building AI. So that AI that you see that you are using for to be productive was built by someone somewhere who is also a software engineer. So you also have that responsibility to be able to build AI, and of course AI solutions. So those are the two, how put it summarily as how we relate with AI. We use AI as a tool, as a productivity tool, and then we also responsible for building AI. So now, software designs of 10 years ago should not be used today. Why? And I'm not going to take input from here. I'm just going to talk to it. So how we build and design software in the past was based on the infrastructures and resources that were available at the time. So at the time, we are limited by compute resources. We don't have as much resources as we have and all of that. But these days, we now have better compute resources, a whole lot of, and it's keep on getting better. NVIDIA keep on opening things up for us. With that, we can no longer use primitive way the same way we design software 10 years ago to design software like that same way in 2025. What we are designing will not be up to chain. You will not meet the dynamics of time. And how do I mean? The inputs, outputs of our softwares, need to change. Software primarily were designed, inputs were designed to almost all the time. 10 years ago, input has to come from keyboard. It has to come from keyboard. You have to type in from keyboard. But that's not natural. Human is not natural. It was just invented that you have to type something on the key so that it comes into the system, and it was designed that way because the computer at the time of that keyboard designs, input designs, could only take input that way based on the resources that he has. But that's not how human actually behave. That's not our behavior. So AI is changing dynamics of making things a bit more natural. So I can just see my computer and I just talk to it. That's natural. I don't want to type. I just want to talk. And then your system should be able to take that. You shouldn't force me to start typing. I don't want to type. So when you design these days, you should have that in mind, that you should be able to take commands, inputs from voice. You see an array of applications that have been built that are doing that already, and of course the output as well, not just voice. You can also take videos, you can take medias and all of that as inputs rather than just a line of text. So we have that, and of course how output as well, how we get responses always have to be maybe on screen, the monitor, output devices, all those things like that when you're learning basic computing. So that has to change in 2025 when you're designing your system. So when you start up designing, that's your system architecture, you have to put that in place. When you start designing, that's your entity relationship diagram, hierarchies, all of those things like that. You should be aware of the resources that are so you should be aware when you're designing that system. You should be aware. You should be say, hey, we are in 2025, and then we should not always say, okay, when you're typing in your this thing, it should always be that way. So I'll keep it that way. So we should not design it this way. Something has to change. Now, when we are building AI systems, what are the options that are available? What are the options that are available when we are building AI system? Now, we are not all of us will not be, we are not compelled. All of us are not compelled to all build model. We cannot all build models. We cannot. But some of us we are compelled, or it's a responsibility as software engineers that we have to build in 2025. System that we are building must be an intelligent system, and to do that we have to do integration. So integration means we are integrating existing models, existing AI systems that have been built, and then we are putting that into our systems. I'm not talking about using AI as a productivity tool now, so that's not bulk of my conversation. My bulk of my conversations will center around how you build it your own self, how you build an AI system. So you have option of integration, which is of course the easiest option out there. Um, OpenAI have their API exposed. Uh, Gemini they have their AI exposed. Claude they have AI exposed. So the same thing that they are doing on their own platform that you're using, as you have, that gives a capacity or capability to be able to do something similar in your own application, not outside it. Within your application, you can have a view where some magic happen using the API system of any of those big players. So what you are doing in that way, you are integrating because you didn't build the model. But you also have an option of building model. You can set out to develop a model yourself for a specific domain and then use it. So that way you are building a model similar to maybe OpenAI model, similar to Gemini model, or whatever model, and then putting it out. I'm going to be talking more about model development later on and the costs association. Of course, you can also have an hybrid of both. You can have a model because whatever model you're developing, hey, let me let you know now that it cannot compete. It doesn't stand a chance. Whatever model you are building, at least from Nigeria. I'm not talking if you're based in the US or you're in China. And from the knowledge I have, whatever model you're building, you don't stand a chance to compete with OpenAI model. You don't stand a chance to compete with Gemini model. So what you could do is maybe you're building a specialized model that's only knows how to do a particular thing and knows how to do it really well, rather than a general purpose kind of model like the big players model. So you can have that in your system, or then also integrate for other stuff. You can then integrate other guys' model. Mr. Jibade, you're raising your hand.
Yes, sir. I want to ask if the session is being recorded, sir.
Yes, absolutely.
Yes.
The session is being recorded. Let me double check. Yes, it's being recorded. Now, so you can have an hybrid of you using your own model and then integrating other parts from the big players model, who you are sure that would always they keep working day and night to surprise us all the time. And also, in fact, it's also now possible to integrate. While integrating, you can integrate multiple models. Maybe for a particular task that you're trying to do, OpenAI caught it better. Maybe OpenAI model caught it better. Maybe for a particular task, Gemini Flash maybe caught it better. Maybe for a particular task, Llama caught it better. So you can have all of these models used in a single application. Each of them focusing on particular task. So as software engineers, this should be more of our focus in 2025. So all of this we already know. Everybody on this call, I assume, already. Nobody on this call is not aware of OpenAI ChatGPT or Google Gemini, DeepSeek, which came by surprise from China, and then Claude from Anthropic, and of course Llama from Meta. So each of these are developer documentation. What I put here are developer code documentations. This is not the UI that you use and do all the stuff like that you do. I'm not here to talk about that. That's too basic. So you can come here and then look through some of their APIs and see what is available, and then that can inspire your new project. So we are going to be doing a deep dive into Llama specifically. And why Llama? of all these guys here, Llama releases his latest um, model just this month, April 5th, and that's Llama 4. It's always been Llama 3 that we're using, then Llama 4 is released, and again also Llama is open source. What that means is that if I have the infrastructure, I can have it deployed on my own infrastructure, and I don't have to pay to use the API, the APIs, the capability of Llama. Unlike every other ones, ChatGPT, when you use it, this guy here, you pay per, uh, they have pricing models that you can check out and see how you use it. So when you integrate the AI, when you per API call, of course, there's a cost associated to it. So, but DeepSeek is also, they have open source, they open it up, and of course Llama also opens. But capability of Llama is way, especially the Llama 4 Maverick and the Scout that has just been released. It's way more capable, and that's why I just want to talk about it a little more. But of course, most of the things I'm talking about here is also true of some of the other models. It's just that most of them do not open it up for um, it's not open source. Although OpenAI, their name is OpenAI, and they say that they are going to be making a lot more free. But what we want to be free is the same model that they are using, not use a model that is not so capable and open it up, and then you are using another model for your own operations. So we want the models that you use, and that's what Llama does. Okay, so Llama 4 is a multimodal model. What that means is it can process and reason across text and visual input. So it can reason through video. You can give it a video, and you can watch the video by itself, analyze it, and then whatever you want to do right there. It's these things. It's very capable. They release it, like I said, this month, and I've tried to look at this thing, and it's mind blowing. It's a mixture of experts. It has a lot of experts within it. So it's a bit more efficient, and it's a family of models. Actually, there are about 3 or 4 family of models within the Llama 4, but the spotlights are the Scouts and the Maverick. Each have like 109 billion parameter, but then 17 billion active parameters. But so they have like 109 billion parameters. That's a lot when you know what I'm talking about as an AI person. And and with 128 experts. So when we say 128 experts, what it means is that it's experts in 128 domain. And then an expert is not the kind of expert that we talk about in this area. When you say somebody is really an expert, it's an expert to the core. So it's very capable, and of course, enhanced reasoning and coding. It's able to code, and is able to reason pretty well. And of course, it has a longer context handling than any other model available out there. Google Gemini has 1 million token context. This has 10 million token context. It means that it has that context handling, because for the lower, the more compact, the better for some of these models when they want to understand context. So but this guy has an extensive context handling. 10 million token means word. When you talk about token, individual word is a token. So like if I say multimodal, this will be translated into a single token, and that token will have an ID. So what we're talking about in a context, it can handle like 10 million word at a time. That's a lot. So, and best of it all, they made it open source. It's open source. You can use it, and of course you can also use it off other platform as well that have integrated it and use it just pretty much like using OpenAI models. So In case some of us do not know, ChatGPT that a lot of people use, Gemini, DeepSeek, Claude, Llama, Copilot, a whole lot more, are all just large language models. All of them are just LLM. All of them. So we need to understand what LLM is. Although I'm sure that not all developers are so much interested in going deep, they don't want to know what is going down on the ground. And I promise today I'm not going to go mathematics. I think the last time I tried to do mathematics when I'm trying to explain AI, it got boring and people were not interested. So I'm not going to do maths today, but there's a lot of maths going on. Uh, under the hood when he talks about when he talks about AI, there's no magic. There's no magic anywhere. It's just about mathematics, a lot of it. So we'll talk about how LLM works at a very high level without going too low, like I mentioned, because when we get low, it becomes uninteresting. People do not understand what we are talking about. So the first AI model, sorry, not first AI model, sorry about that. The LLM, all these LLMs, most of them, not all of them, the most capable ones were based on what we call a transformer architecture, which was released in 2017 by some researchers, most of them from Google um, research team. And that model, that transformer architecture, centered around what they call attention mechanism, and it was specifically designed to translate German, English to German, of course, and French. Those are that was their focus. But during that, um, they discover a whole lot more that is possible during that endeavor. As developers or as engineers, sometimes what you set out to do is just A, but while you're doing the A, you now see that, oh, B, C, D, E, F, G, all those guys are also you know possibility is endless. So when they open it up, they now say that, okay, why don't we apply it here, why don't we apply it here, and then that's why that is what brought us here in this AI ecosystem that we have today. So I'll just try to explain a bit what that internal mechanisms of that uh, attention is all you need. Um, Transformer architecture um, does that's that basic one that they did in 2017, in 2017. 2017 looks like a long time ago in AI ecosystem. It's a long time ago because a lot has happened after that. So pretty much you have an encoder and decoder system. Encoder works about input, and decoder works so much about getting the output ready and then getting it represented like that. So there's a lot of processing coming through. It takes inputs, how the input get processed, how it encodes into the system, how the system understand it. System does not understand. It's better for system to understand. System understand is, binaries, 0 and 1, yeah. But we are not talking from that perspective in that context. So we are talking about how does system understand what I'm saying when I say I'm a developer. You know, it will be easier if these numbers, if this I am a developer is translated into some sort of numerical, and then numbers are easier even for human to remember than this thing. So it's also true for computer. And so when you are encoding system, there's what we call embedding, and that's where the token that eventually now used in the most of the models that we have today, or sorry, on all the models that we have today, is based on token. Everything that you are telling the computer, it will, when you're telling your models would be first of all translated into token, and then that token will be embedded, and it's through that embedded that it understands the context, and then from that context it decodes it, passes it, and then translates it to the later this thing. Before this transformer architecture, what they were using is just a neural network, natural language processing, NLP, and then it's based on maybe artificial neural network, recursive RNN, and all those things like that. And how that works is that contexts are translated word by word, and it's not so efficient. Like I'm a developer, I will be translated into I in German, am will be translated into am in German, developer will be so. one after the other like that. And that's not how language should be translated. Language should be understood first. You should say everything you want to say, then I will understand it first, and then I can then translate it into the other language, because you cannot translate word for word. At the end of the day, you have garbage. And so this was a problem of the initial models, initial neural networks that were developed for language transitions. So they were not able to effectively translate language to language properly. And so that was the problem that this guy set out to do, that understanding context as a whole before trying to, translate that context. And that's, I can tell you, gives us the foundation to the most of the advancement that we have today. So I will keep that short. So when we talk about the transformer architectures, the most commonly used ones are the GPT and the BERT. GPT mostly used in most of the models. Of course, OpenAI, we are used to saying ChatGPT, but most of the other models also use. So GPT is generated pre-trained transformer. It's nothing specific to OpenAI, and of course, BERT was initially the transformer architecture that was used in Gemini, which is of bidirectional encoding representation for transformer. So these are both transformer architectures, and of course, both of them work similarly, the same way. Input, processing, encode it into the system, everything, understand it, and then before you start talking about working on it and getting output out. That way, you stand a chance to perform better. Now, building a large language model, there are stages. There are three basic stages of building an AI LLM. First off has to do with data preparation. Data preparation within the first stage. You get the data sampling, batching the data, and all of those things like that. And this involves whatever you want your AI to be intelligent about. If it's about coding, you are going to have to give it, the various data and all of those things about coding, so it knows how to code. If it's about engineering, whatever you want your model to be intelligent about, it's going to have to be specifically trained based on the data. And so the data has to be prepared very well. There's a lot of mechanisms under the data preparations, missing data handlings, noisy data removals, and all of those things like that. A lot going on in there. This session will not allow me to, do a deeper dive into each of these domains. So, like I said, I'll just be talking about them on at the surface. So when you're done preparing your data and all of those things, and your data is ready for the AI to start learning from them, you then feed that into your model. You begin to train your model based on that data. Now, when the LLM is learning from your data, it doesn't learn. It learns everything, but then there are some parts of your data that are more important than the other. So any statement that human makes, or any statement that we make, all of them, not all part of that statement have equal importance. Some of them are just there. If you remove certain word from that statement, people will still be able to understand what that is about. But if you remove certain word from a particular statement, it loses meaning. It doesn't have any meaning. So AI was the model was built with attention mechanism, and that's what that paper I mentioned earlier was much about. Attention is what we need. We need to ensure that when we are learning from data, we don't just learn randomly everything, blindly. We have to know which part of the data is the most important and focus on that part. And that is what attention mechanism is about. Like I can tell you, it's a lot of mathematics under the hood, a lot of tensor, multi-dimensional matrix multiplication, and all of those things. Multiplying attention weight, because each of these words have a weight. So based on their weight is what we know which one has most important. Then there's what we call affinity calculations, and then difference distance calculations. How each of the words are are far apart from one another. There's a calculation for that under the hood that makes it know which of the word, which part of the data is most important. Then it focuses on that and get it out. And then, so even when when AI trying to respond, when a model is trying to respond to your query, it's the same thing. When you asking it a question, it uses the same thing to understand your question before it gives you an answer, and then it uses the same thing to learn as well. So there are different type of attention mechanisms. You have self attention, multi-head attention, and all of those things like that. Here, that's the core of AI modeling. That's the core. Of course, you have the LLM architecture. Then you have to select which LLM architecture you want to use. Barrett, any of the GPT. So why most models also use GPTs? You use a pre-trained model, a model that's already been trained on how to follow instruction. So you don't want to start from a model that is just a dumb. Is as dumb as anything. He doesn't know nothing. He doesn't even know how to follow instruction, because one of the most important thing that model should know is how to follow instructions. Once he knows how to follow instruction, then you can the rest, it's easier. You do this, then it can follow that. Learn from this. Fine tuning becomes easier. So GPT is a pre-trained model. You can use a pre-trained model that already knows certain things, basic stuff, and then they are easier to train than a very dumb model that knows nothing. Then, of course, once you have that established, the next thing would then be stage 2, which is training loop. You are going to have multiple training iteration. AI doesn't learn once and understand once. No, it's not possible. You are going to have multiple iterations. They call it epoch. It will go through it again and again and again and again and again, and then you'll be monitor. There's a test that you do, an output that you text to see how coherent is sounding, So you see it that it begins to now, output something that is much more coherent. Then you know that it's becoming more intelligent, and then maybe after maybe set out for instance 50 iteration to go through that data, and then at the end of 50 iteration, you say like, okay, I think the output that we're getting looks more like it, and in that live we talk about fitting, how it fits. So if it is not, you go again. This is programming. You go again, and then maybe we need to do more, or maybe we need to do change some things in the data in our data source and all of that. Then when you feel that your data, your model has learned, and you feel that it's intelligent enough, it has to be evaluated. We all go to school, and at the end of every term or every semester, we get tested based on what we say we have learned this semester. That is evaluating our understanding of everything that has been learned in that semester. So the same thing, after training your model, you are going to test it to be sure that it performs well based on the data set that you've given it, based on what it has learned. So the data will be divided into training sets, and of course testing sets, and all of those things, and you use that to see how it performs. If it doesn't perform well, of course you have to go back again, and the training continues. And then you are going to load pre-trained weights depending on, initially, the guys that started the LLM ecosystem, they've worked so hard that we have a base weight, training weight. This weight is important, like I mentioned, for attention mechanism. So this pre-trained weight, maybe from OpenAI pre-trained weights, I developed a model myself that I'm going to show. So what I used in this pre-training weight is to after training the model and evaluating it, of course in a very small data set, loaded. At that time the performance is low, but then by the time I loaded the pre-trained weight from the OpenAI, which enhanced its attention, the performance became better. Still not as good, but became better. And then of course that's when you begin to do fine tuning and all of those things like that. Then after that you do fine tuning. You have fine tuning, which is about, you know, this guy already knows how to do this. You can then just change. If you can do it on data A, B, C on data A, you can also do A, B, C on data B on different data sets, not necessarily the same data. So, but of course, maybe within the same mechanism, using the same mechanism on another. So that's what fine tuning is about. Not necessarily the data it trained with, but another data set like that. So we have that, and then mostly initially you have AI as classifier. Like I said, a lot has happened in AI ecosystems, and yesterday feels like a long time as far as AI ecosystem is about. So you have to keep touch or to know what is going on at all the time. Like I mentioned, Llama 4 just released their latest, most capable this month, and it's a whole lot. So initially, you just have a classifier, maybe classification to know what is good, what is bad, failure from success, other stuff like that, and then personal assistant for whatever, like ChatGPT, write this thing for me, write that for me, and stuff like that. But you know, we are now applying it in so much more, which of course you can categorize it as a personal assistant, but then it can be much more than that. AI is more capable. AI is bringing naturality into computing. Let's summarize it like that. So the natural way of human interaction, the way we interact. I don't want to share my Wi-Fi with somebody. I have to go and click settings, you know, do that. Why can't you just touch? I want to connect with this my Wi-Fi. Why don't you just use my phone to just touch that your phone, and then automatically we connect. That is connection. We don't have to necessarily. So AI, people are changing the game, and then we should be part of the conversation. That's all. Uh, that's what this whole conversation is about. So understanding what embedding. I talked about embedding while I tried to explain uh, the transformer architecture at the surface. And this is a transformer architecture as well. So this is an example. This is how it works. When you're training a model like this, you say this. Giving it this. This is an example as a data. This is an example will be split into various words. This will go in is an example dot comma. Each of them are separated and they are length differently. Each of these would then be converted into what we call token. So we have this token ID. And this token will then be embedded, you know, and then you have a decoder transformer who works on it, processes it, and then before you get an output as a text. So this is how, you know, things flow, basically. Now, understanding attention mechanisms, I've talked about this before, and I mentioned that it's a lot of maths. At the low level, it's a lot of maths going on. A simple one though, tensor for mathematicians on the core. It's just tensor calculation, which is just matrix, multi-dimensional matrix dot product. So you have each of these attention weights. You have this is it. Each of these attention weights have their own distance, and then you create you try to find a dot product, and that will give you how close or how far apart a certain word is from the other, the central one, which one should be distance, and most importantly attention weight. So maybe after the course some of us can look up attention weights as it relates to attention mechanism and try to understand it more. On this call I can only, you know, explain as little. Now, model deployment. Now the model deployment, whether it's a system that you have built that you just integrated AI like OpenAI, or any of the big players model that you integrate in your system, or you have built a ground up models yourself, how do you deploy? So you have two options. One is on premise and the second one is cloud. And I would be very specific as well when we talk about premise deployment, because we are talking about AI now. It's not most of these things cannot work efficiently on our current system architecture like a CPU. It works, but it's going to be slower than a snail when you try to run it, and you will not even enjoy the experience. It will learn before you can even train a model successfully. Maybe it's going to take you three years or 4 years and one is going to learn within that period is given very minimal. So if you're going to use, so most of the infrastructure that we have in our own place here, most of them are based on CPUs, and then so that's its failure at ab initio. So you are not, you don't want to go there. So if you want to do a premise, then it's going to be overhauling of the infrastructure that you got, and then changing the CPUs to this GPU architecture. And then of course a lot of investment would have to go there. It's not cheap, it's very expensive. It's not cheap, it's very expensive. And that's why when DeepSeek came into the arena, and they said what they spent in training their models and getting everything ready was approximately $5 million. um, our American community tried to say it's a lie, that is not possible, that it's not possible that they get something out. $5 million is a lot when you talk about in Nigerian context. So, but then people still try to say that it's not true, that they did not, that they trained their models with under $5 million, like that. But later on, we got to understand that it was more about efficiency, how they wrote the code such that it doesn't have to work on distributed GPUs, that it can work on, even a single GPU, and then you can get this thing as, and it doesn't have to be on the latest NVIDIA GPUs. And that forced them, they could also have just built it the same, with the same enormous money that other guys have used. But because at that time, America tried to block distributions of infrastructure to China, just so that they can control the AI market. And they got surprised, they got a shock of their life with DeepSeek, developing a very performant model with a very a cheaper amount. So bottom line is that the infrastructure that we got are not sufficient. It's a lot of money when we talk about AI. So I've seen some of the people in Nigeria that they say they are working with AI. They are working on models, and they say that this thing, and that they say that they are deploying it. They are working on their computer. You see it on social media. People are uploading, but the truth is that they are not. That model is not their model. It is not. You cannot. You don't have that money to even train a model. You don't. If you have $5 million or $1 million, people will know. So that is there. The cloud infrastructure, cloud Azure, AWS is a very big player that you can have your models deployed in there. It's a lot also more expensive when you deploy it in there. You are going to have to pay for compute resource by per hour and all of those things like that, and it's also very expensive. Maybe on the minimum you are going to spend like $5,000 if you're doing the AWS stuff like that per month and all of that, trying to get your maybe your models deployed. But thank God, or thankfully, we now have most of the VPS people who use, most of our host software engineers, we use, some of us who are not using Azure's cloud or whatever it is, some of us use VPS. If you don't have money, if you have low budget, you use virtual private server, that you will be the engineer who set up everything yourself and all of those things, if you have that technicalities. So some of them are now, they have upgraded their infrastructure and they're now making GPUs available. Although I found out that some of the GPUs that they acclaim GPUs are also still CPU, but then with enhanced resource. But of course, it will be better than you having it on your own infrastructure, local infrastructure. So it's way cheaper. So Google with your friend when you are ready to deploy your application, to check the deployment strategy that is cheapest. But when you are picking any provider, you have to look for their history, how long they've been in the market, and all of those things like that, so that your data will not be on their server, and then tomorrow they say they are going out of market, and all of that. So we have to be careful with that. Now, so again, I think I've been hacking radio for the past couple of minutes, so I want to open it up again. So I saw this online, and this message is credited to our friend, our boss, Mark Zuckerberg, who said that we should say software engineers should say goodbye because AI is here. So we should go find something else to do. So let's talk about it. Who agree with this statement? Yes, Mr. Ajibade.
Yeah, good morning once again. Well, personally, I I still ask myself that question, but well, I don't really like using AI myself from the beginning because sometimes I believe it makes me feel lazy and you know I'm not thinking enough or things like that. But lately, like I would say over the past 2 months, I try to, actually use AI and see, okay, what can it do and all. And well, it's great, it helps, but I would say from what I have imagined how it could be, I am disappointed because I thought it would be better, that it could actually replace me. But I would just say it complements me rather than it will replace me.
Okay.
So that's just my own
Sorry, I want to
perspective.
get. You say you are disappointed with AI. You thought it can do better.
Yes, sir.
What were you expecting? What were
Like the
you
way people,
expecting that is going to make an human being today or tomorrow? What were you expecting?
yeah,
What
what
are your
I
expectations? Yes.
Yeah, so why I said I was disappointed was the way people talk about how AI is going to replace software developer is so intriguing that you think it can actually get everything done. But to my surprise, it still needs help.
Okay. Sorry.
So that's why I
Yes,
said,
I get you. I get you. But what did you try? What did you try? What have you
well,
tried?
okay. Yeah. I was trying an implementation actually. So I hit a block. I actually know what I can do, but I just feel like okay, maybe it will have a better approach. Then it gave me the approach and I tried it. Well, before I
Which
even
model
tried
did
it,
you
I
use?
could
Which
tell.
model did you use?
So
Which model did you use?
I was using ChatGPT
Is
actually.
it free
I
version?
don't
Is
know
it
yet.
free version or did you pay?
It's probably the free version.
Uh-huh. So
Although somebody
there
had
you there you there you go. There you go. You use
oh,
free
all
version. So the thing is that
right.
yeah, I will talk about it later on. Mr. Michael, you want to.
Yes. So the statement is a two-way answer. It can be yes, it can be no.
Okay.
So yes, in the sense that it might reduce the number of software engineers that is needed by a company. And I think the people it's going to affect more is the upcoming software engineers. When you are new to the game, you don't understand the concept of software engineering generally, you might not have a chance. But if you're smart, you can leverage the AI tools to actually come up faster. But for the veteran, like Mr. Lukman that is here, AI cannot replace him because he understands software engineering to the core. So from my experience, what I've noticed with software AI generally is that AI it's just a tool to achieve a goal. So for simple problems, you can easily use it to get something done quickly. But for more complex problems, you might need to have someone that's experienced to actually give you the right prompting. So I think when the first person was talking, even with the free AI, you can actually achieve a lot of things if you have the correct prompts. It's the way you prompt AI that you can get the result of it. And you don't rely on just once. For example, I've used Claude, I've used ChatGPT, I've used several of them. I know the one that gives me answer based on the problem I'm solving. Sometimes I can prefer Claude and it gives me a very good answer than even ChatGPT. So it depends on which one. And if you want to really enjoy it, you have to pay actually. You have to pay to see the capability of AI. So it's a yes and it's a no question at the same time,
Okay.
depending on which of the software engineer we're talking about here. Thank you.
Thank you, Mr. Michael. Thank you. Mr. Usman.
Okay. So I'll still stay on the perspective of the previous speaker, of the previous comment here. So the reason is that it could be yes and it could be no, and that is dependent on the factor, like the person himself or the software engineer himself, because like the way artificial intelligence is going now, so it's likely create more jobs, like to open more roles, if not even so, if it is not even software engineering roles, so to create more roles, and it has even been creating more roles right now. So, and yes, it will definitely scrap off some roles, some basic roles, some things that they are just basic things, they are foundational things that that is just foundational, right? So software, I mean, artificial intelligence will scrap that off. So, but what will make AI not to scrap you off is, as a software engineer, is to use it, like use it as your companion. So if you are using AI, like if you are using leveraging on AI, so it might not scrap you off. But if you are not leveraging on it, so then definitely, so it will scrap you off and forget about it.
All
Yeah,
right.
thank you.
Thank you, Mr. Susan.
Good morning, sir. Good morning, everyone. So this particular topic is something that like I usually think about most times because it's all over the internet that software developers soon would not have a job, and is high time for them to get into something else. And but just like the previous commenters said, that you have to leverage AI to work. It still gives me concern because this week I saw a post, and even on YouTube, where a senior developer is saying that making AI your core companions would reduce your problem-solving skills, in that most developers, not for the seniors, like those that are coming up, if they continue to use AI to debug and solve most of their issues, that in the long run, they would their career will be affected very well, because that debugging skills will not be there, and software developers are known for people who solve problems. So it gave me some concerns. I was like, okay, should we use AI or should we not? Or how do we find a balance when it comes to using AI to work, like in our place of work? The post was like, for those that are still building their skills, they should reduce the rate at which they use AI, so that they can get to know how to Google and use Stack Overflow, and learn also how to debug, like gain the debugging skills. So the whole thing is just confusing me, because informations are just everywhere, not knowing which one is true, which one to follow, which one to, So I don't know.
Okay. Thank you, Susan. Mr. Usman, you want to go again?
Yeah. Like
Okay.
I said earlier, I said software, like you said as well. So software engineers are problem solvers, right? So AI is something that AI too it solves problem. So, but what AI lacks is AI lacks context, right? So it is human that understand context, that understand how things should work. So AI does not understand feeling, does not understand. So it is software engineers that understand all of these things, and they can come up with
So,
solutions
sorry, when you say
that.
AI like lack context, what do you mean? I want to get that
Yeah,
part.
what I mean by that is, what I mean by the context is, so except you provide context, right? So as a software, it's very except you provide meaningful context or full context of what you are trying to solve to AI. So AI cannot reason like with things. So even if AI can, if you can give context to AI, so in cases where, okay, um you have problem you want to solve, and you cannot even describe what you want to solve, right? So to AI, so because AI cannot just think on say, what that's what I mean by context.
Okay.
So you have to give it
All
what
right.
you
All right.
want.
Thank you. Thank you. Mr. Ajibade, you want to go again, please? We still have question and answer session, oh. Well, so that we
Oh,
can manage
sorry
this.
about.
Yes.
I wanted to talk about what Miss Susanna said regarding not using AI to debug. Well, I don't know, but in my own perspective, uh, when I use AI to debug, actually, uh, it kind of give a direct solution a lot of time, and that means it saves me a lot of time to read a lot of articles or something. But what I do personally is, whenever I do this, I will have to ask step by step on how we got to that place, and I try to promise myself that next time I don't go back to ask that question. Now I know it.
Okay.
So I would say it's not something you don't use AI to debug at all.
All
Yeah.
right. Thank you very much, Mr. Ajibade. Mr. Shams, you have the floor.
Thank you very much. Please confirm if you can hear me.
Yes, we can.
Okay. Thank you very much, Mr. Kenny. Thank you very much, everyone, for your contribution. Me, I want to speak as a teacher and as somebody who is at least dealing with young people for quite a number of times now. When we were growing up, there is a lot of opportunities to expand our knowledge scope because we have access to research materials and ability to twist it and use it to be able to learn whatever it is that we have learned today. But I am worried, especially because of the way people nowadays are using these tools. Say, for example, I told somebody to write an appreciation letter yesterday, I believe yesterday, one of my people at the office. And then she just gave me that context. And I looked at it and I feel like this is just ChatGPT material. And the person has been doing it repeatedly, and I've been trying to make the person realize that it's not, I'm not a, I'm not an opponent of AI tool usage. But can we at least bring our brain into the fore when we want to use this? Can we make it a tool to be able to demystify things and then have that knowledge that when they wake you up, you'll be able to defend whatever it is that you do at the end of the day. And if you look at it, that rate is the rate at which people actually have depth in whatever it is that they are doing is reducing at a very alarming rate. That's my own fear, actually.
Okay.
And I've
Thank you.
I'm coming to and I've seen it played out, on several occasions. So AI is not going to, take our jobs, but the people that are now doing the job, can we also be intentional about ensuring that we have depth in what we are doing, such that if anything happened today or we find ourselves in a very complex situation, we'll be able to bail ourselves out. Thank you.
All right, thank you, Mr. Shams. So that's a bit we will take. Um, so before I talk about my summary of what everybody, I appreciate everyone for their inputs, and I think we'll dissect it a bit more in the next few minutes. Before I talk about it, I also want to put another context. So to have insult to injury, after Mark Zuckerberg's statement about that we can go to and start playing football, that software engineers should go, that we should say goodbye. There's a leak recording in Amazon Cloud Chief, when Amazon Cloud Chief was telling when they were having an internal meeting. In a leak recording, Amazon Cloud Chief tells employees that most developers could stop coding soon as AI take over. So they are preparing for AI takeover, so some of them would stop coding. AWS CEO Matt Gaman, or whatever you call him, shared that thoughts on AI during an internal fireside chat in June last year. So this is the leak message. So, and then AI is coming for a job. So we've seen this repeatedly everywhere. But how do we make sense of these three things together? Now, so if it was just this Matt Gaman, people will not take it serious. Because his background is industrial engineering, he has a bit of product management, so not so much of a software engineer himself. So, software engineers, they don't take you serious if you are not a software engineer, if you are talking to them. That's what I know, that much. Then, except you are their teacher like Mr. Shams, who, have something to teach them. So, but when you say, they will, first of all, check you up. But then, this guy that people put as the face of this statement is a software engineer. Mark Zuckerberg was a software engineer, and he still is, and he loves coding. He still tries to get involved with codes and all of those things, even at his level of influence in life. So he still get involved, because also in the game, you will always be in the game, the same way we begin. So he's the face, and then you have to take it serious when you see this face saying that, because you know that he knows what he's talking about. But then his statement was taken out of context. That's what I would say. I watched the video. It was a video, and it's on YouTube. You can go watch it yourself. You'll see this guy is talking about it in this thing. So what we talked about is what some of the people made the comment also talked about. But before I say that, I would first of all talk about what Mr. Michael talked about prompting. So if you want to get the best of AI, if you want to get the best out of any expert, it all has to be the quality of your question. The quality of your question would determine the quality of the output that you get from them. So if you are with them and all you're asking is what's the name of your mother, so they will tell you they will give you answer based on the questions that you're giving them. So prompting, it's very key when it comes to the answer that you're expecting from an AI system. So even the most basic one can perform the best of the best brain. So that has been established, and it keep getting better. We are scared, and I have to state that I am in 100% in Mr. Sham's lane. In other parts, in terms of I'm always against no code. I know some no code people are on the call. I don't like it when you bring the system up and you say we are not going to code. It's a system that it will code. It's just going to be some blockchain that we are going to be putting together, and then the output will just be boom, and then we'll have it like that. But AI is not no-do. It's not a no-do kind of tool. It's not a no-do. It's an enhancer, just like some of us have put it. And then it all depends on how we are using it. So when you say you are being productive, you are using it as a productivity tool. You are automating. But then when you automate to build what? What are you building? That output needs to be answered for us to know if you will be replaced or not. If what you are building is the same hello world that you have been building before AI, know that your days are numbered. Your days are numbered, because that hello world that it takes you 3 months to build, AI will build it in 5 minutes, less than 5 minutes. So there's no reason to keep you. So, but if you're using AI to build something that you even yourself do not imagine that you can do, you use it as a companion to break walls, something that is unimaginable, then you will remain in the game. You will remain in the game. But even if Mr. Michael said that even if you understand engineering and you understand all of that, it all depends on what you're building. What are you working on? So we have to ensure that we are building something extra that is relevant um, within time. It is relevant during this period of AI. Otherwise, AI. So what this guy said, going back to what Max Sugara said, was that um, it will replace, just like Mr. Michael has put it, it will replace some developers. Um, and let me put my own, because I'm out of time now. I read and I have not even shown any practical. So this is my own take. AI it will not replace engineers. AI will replace software engineers. It doesn't. It will not. It will not replace software engineer, but it will replace some development roles. You know, so engineers will collaborate with AI tools to build AI solutions that solve problem. Engineers will make more money. They are already making more money. There are things that they don't know that is possible. With this AI now, they are now doing it, and they are making money. And I cap it up by saying it is more accurate to say that software engineers are taking jobs than to say that AI is taking jobs, because the software engineers are behind the AI. But what Max Zuckerberg also said in his video is that there will be AI that is also responsible for building other AIs. AI can build another AI, and like that. But software engineers identify problems like outside the context problem, not within context. Within context problem, AI can understand. But outside context, these people, this industry have this problem. Then we need to solve it and all of those things. That outside is not within the loop kind of thing. So it's outside the loop. Then you put your team together. In your team, there will be AI in your team. You are working together to be another AI system that solves that problem. That's the essence of this session, and that is the way we should keep it. We continue to think. Otherwise, I can tell you that AI is coming for you, and it will take that job, even if you're a software developer. And also, I'm going to talk about the opinions. When you take opinions from Mr. Susan that talked about, you don't even know what to. So when you listen to us as people who talk, you have to filter whatever you are picking. You pick from us. You have to filter. You don't take it 100% that because this guy is good. I might be a good software engineer, but I might lack certain experience in certain things I'm talking about. So you have to filter whatever we say. Also, match it with other experts, what other experts, and what data says. And that way we would be able to have the scientific this thing. But opinions remain opinion. Whatever people say on YouTube, everybody have their mic and they can say whatever they want to say. But it remains opinion, except it's scientific. And most of them are not scientific, so we cannot take it. So if it is at this surface like this, I disagree with what this guy said, but it can also be true if you don't take advantage of the AI and do bigger stuff. Don't continue to do. If you continue to do basic stuff, you are gone. So that is that. So I will just show a bit of practical session. I'm out of time. I'm spending outside the this thing now. So I will see how fast we can do that. So we are going to share this later on for people who want to see some of the implementations of Google Gemini. So you can have this repository and have a look at this repository. You can have some inspirations for your next project. Now, so if you look at this is Google API documentations. In this Google, if you want to do integration, so we are all engineers or developers, so we know how to go through API docs, so you can see what is possible. You want to do some video generation, image generation, text generation, computer vision. Computer vision has to do with computer being able to see your screen, computer being able to see, maybe we want to share screen, computer and stuff like that. So there's a lot that can be done with these integrations like that. So you can check up each of these household guys, maybe it's Google, Gemini, and stuff like that, and check their pricing. You can see this is OpenAI documentation. You can see how you can integrate some of their capability in your own system, not going outside to do in your own system that you are building for your clients. And of course, like I mentioned, there's more opportunity for us. Most of the systems that we have built in the past were built the old way, even if they are built the right way at that time. So it's a huge opportunity for software engineers who make use of AI to do bigger stuff. It's endless. This is our time really to take everybody else's job, So we are going to take their job. But don't tell Mr. Shams. All right, so this is Llama. I'm going to download down on Llama before I show my own. Before I show a bit of my own model, internal mechanism of my model that I worked on. So this Llama here, like I mentioned, is open source, and then you can have it deployed on your own infrastructure. I have one that I've deployed on my infrastructure, and of course I make use of for this session I just use a code base that is not also written by me, but the code base from the Hugging Face community that makes use of multiple large language models together. It makes use of you can use Gemini if you want, you can use Llama if you want. So in that, and of course also uses Llama, OpenAI GPT as well. So that project, I just used that project and just created the same thing that they created, not adding anything to it. I just run it on, deploy it on an infrastructure just for us to see. So you can also check out that repo. It's called Slide Deck API AI. What it does is it generates slide deck, so you can ask it to we want to do a presentation. You can just say generate a presentation, a slide deck on artificial emotional intelligence to create that slide for you. Very good one. Then you can use it as a base and then build on top of it. So you have that. So I'm going to show that. I'm trying to rush through and see. Then some of the things, and then I equally have a cloud pricing comparison that you can do. So go with your friend, you can actually do that here. Now I would go to the, please let me know if you can see my screen. This is the model that I worked on. The so this model, it's part of the research that I'm working on. I've been working on for a while, and like I mentioned at the start of this session, privileged to be part of the 42 Nigerians selected to lay the foundation for AI system in Nigeria, working with Ministry of Communications under National Nigeria's Artificial Intelligence Research Scheme. And of course, as academics too, I'm doing a lot of works on that AI, trying to get what happens and lay foundation under there for the community. So I built a prediction tool for mechanical engineers or plants generally, for plant monitoring and maintenance. So what this model does is just it predicts a failure ahead of time if something is going to fail, and also represent an expert system that can answer maintenance related questions, specific domain kind of expert system. So that is what it is meant to do. Of course, it was inspired by a book, so a lot of books that I read, most of specifically by Sebastian. You guys can look it up, which is building LLM from scratch as well. So this parts here just focus more on fine tuning, because the model has been built, and then it was just I just brought it in and then fine tune it. So while I talk about it a bit, I would um, invite someone to just talk about it within 1 minute, because we're already out of time. Using 1 minute or two to talk about. I am aware the person is working with one of the top 10, one of the top 10 tech giants in the world, not Nigeria. So I don't want to mention the name of that tech giant, but we have someone in the list in our midst here who is working with them, and they are training a model on how to write code. He's working actively on it. So I want him to just share 1 minute of some of the things experienced. Please, you have the floor, the person.
Okay, thank you, Mr. Kenny. Good day, everyone, once again. So my name is Michael Olawuni. I'll just give a brief overview of the project I was opportunity to be part of. Though it's on pause now, but the last few weeks we worked. Just want to explain what we did. So the project is an LLM project. A model has been trained to help developers to query to get a code to build on their existing infrastructure. So there's something called ERP. If you work in large organization, there's one center of truth that they have. Everything that happens in the organization is managed by an ERP. Sales, finances, everything. That's what my so the LLM that we are working on, it's supposed to help the users of that ERP, especially developer maybe in the company, to be able to extend functionalities on that particular ERP. So the goal is that if a developer query the ERP LLM, for example, you can say, I want to have a facility where if a salesperson do this, give them commission, this. So maybe that feature is not existing on the ERP currently, but the developer in that company wants to extend that feature. So it can interact with the LLM and get code and build on top of that ERP and have that interface done. So the task that we were saddled with as LLM trainer is that you use your knowledge of software engineering to improve the AI. And the method used was called supervised reinforcement human learning feedback. So the goal is that the LLM has been trained, but they want to be sure that the output is given is actually correct. So they engage us to actually ensure that this particular LLM, the response it is giving is actually correct. So what we do is that we use our knowledge of prompt engineering to prompt the AI based on the tasks that users are supposed to be done. So there are a pool of questions actually that we need to implement to be sure that the response that this LLM is giving is correct. So what we'll do is that we'll pick those questions and we'll now write a very detailed prompt with context and tell it even the type of functions to use. So the goal is that we'll prompt it to write the code for us to solve that problem, and also for the LLM to also write test cases for that particular question. So upon doing that, the LLM will give us a response and give us its own response. So our task as LLM trainer is that we'll go through the response that's given and discover flaws in that response. We'll now rewrite and ensure that the answer that is expected is what we are giving. We'll rewrite some of those responses, add more functions, add more test cases to ensure that we get good coverage. We'll now feed it back to the system with the new prompts that we use, to get those responses and everything. We will provide context of step-by-steps of what we would do. For example, we'll tell you that for this question, I'm going to ensure that I calculate the percentage first, then I do this, I do that. So you have to tell the LLM the steps you use to solve the question. You now feed it back to the LLM and submit. So that's practically like a overview of what we did on that system as LLM trainer. The model has been built. So our task as human beings is to ensure that the LLM is trained to actually give the right output at every time. I don't know if it makes sense to anyone, but that's basically what we did on that project.
Thank you
Thank
very
you.
much, Mr. Michael, for providing the context, providing explanation to giving us your insights and your experience, training, of course, fine tuning, um, LLM. And this is, like I mentioned, it's a big project that they are working with one of the Big Ten technologies. You can go and Google Big Ten. You will see one of the names in there is they are the one building that model, because they are the one, those are the guys that have money to do such projects. So basically this session, we all agree that within 1 hour, we can, there's little to the practicality that we can expose, and that's why we try to you spend a lot of time talking about theory, context, and then so that we can get the best. Because even 1 hour, if I'm going to start writing fine-tuning code, we can get that. But of course, we will see how we can create dedicated sessions, and of course dedicated videos about um, a deep dive of some of these things. So some of us can have some of us who are really interested in AI. Some of us will continue to be consumer, and that's the posture that we are now. And I have to state before I close. I hope I remember to say that before I close my session. My thoughts about our attitude in this part of the world. So fine tuning is basically just making use of T-token. T-token is responsible for converting um, um, words into token before embedding and all of those things. And of course, TensorFlow is a machine learning algorithm. Mr. Michael mentions about something about supervised reinforcement. So under the large language models, under the hood, we have the machine learning algorithms, and most of them are based on maybe it's unsupervised learning, supervised learning, or reinforcement learning, or a combination of all of them together. So this is the framework that's laid down foundation. These are the real guy. So when we are talking, so we should be talking about more of TensorFlow than talking about OpenAI. I'm not reducing it, but because these are the real guys that are doing the work under the hood. So of course, OpenAI researchers make use of some of these things to do what they are doing and all of that. So TQDM is for drawing. When we do to make things a little more interesting, when we want to do visualization within our own this thing. So we have that. So I will not have that time to be able to go through line after line. This is the code, the data that I use for fine tuning this model. So it's on GitHub. So I just hosted a very small data set, because otherwise I'm having to train on a CPU first before I got a cloud, because the research grant that we had, they were supposed to have a cloud resource, but eventually we didn't have. And then if you continue to wait, you continue to wait forever. So I just had to make use of the resources that I got, at least so I can get this thing that the results I want. So, and even using CPU, eventually I got a GPU and then train it on it and do fine tuning on it as well. So so these are some of the things that I try to put it out. What works, what is happening when you put instructions, and what happens in that place. I try to provide context. I'll see if I can expose some of these things. I will not be able to expose some of the code, because of course it's an enterprise project, and it's something that is going to be monetized later on. But provide some context so that people who are really interested would see how this thing really works. So I try to explain it a whole lot within the code session. At the end of the whole thing, after fine tuning and seeing if you look here, this is the real process where you have to go through the what's it called, the iteration to see how that guy works. And then I then validated it with a llama. So you see llama evaluation here, because you have to validate your model. If you are building any model, you have to validate it against existing standard model and see how it performs. Either it's woefully or it performs relatively well against that. What Llama can do, your own can also do it. What is the percentage shortfall? How does it compare? Is it almost there? Or so that is when you can beat your chest and go out and say, when DeepSeek did their own, they have to go check it on the ground and see how it performs before they start going out to make noise, because otherwise they will be shut out, from the one. So all those, that one is there, and then you have the evaluation, and this is how this one is just talking about. It's a very minimal data, and how a GPU would process it, and then how many minutes it will take for two iterations. So I've got that out. So you can't really get much in this code, really. The way I'm doing it, I know that. So I would expose what we can get at the end of the day. This was actually evaluated against Llama 3 at that time, which has a 8 billion parameter, against my own that's just less than 10 million parameter. So that's another one that I feel we can also look at is this guy here, which I said I do not take responsibility for writing the code, but as the engineers, when we look into somebody else's implementation, it can inspire our own implementation as well. Of course, the way we do stuff. So we can also look at this slide deck AI, which, like I mentioned, uses multiple model, and I have that set up on a cloud GPU that I actually purchased that I'm using to do some AI stuff. So let's see if we can get that out. Okay, 1 minute. Okay, right there. So if you can see my screen, I'll just so I have it deployed and it's working. So I'm going to get somebody to tell me what I should generate for them. So a virtual environment is always encouraged when you're working here. So I have a virtual environment set up, and then I can then just run it with Streamlit, which is a front-end framework for AI development. So that's what they used to do all this UI with. So I have that guy up now on this API, on this IP address rather. 11:41. So I think I have to stop now, even though I wasn't asked to stop, because we need to take the product spotlight. But I will need this guy to come up first before I do. So why this is coming up? Okay, it's up. It's a slide deck API, like I mentioned, and you can use either basic boardroom or minimalistic sales pitch, or whatever style you want to use. I have everything set up. You can use your API key with it, but I have everything set up under the hood and pass my own key right there. So somebody can just tell me to do a slide deck on anything. Anybody, just tell me to do a slide deck on anything, on any topic.
Let's do time management.
Okay. On time management. So you can give more context to the to that what you want and all, but I will just do that. So this guy is working, it's creating it, and when it's done, it just give me my slide. Then I can use that as a base to start my work. Of course, this is generated JSON material. So if you're using it within an application, you can have your own UI which you have. But this is for everyday consumer, like we are. So this guy here, it's ready. So let me just have it up on slide. So you can see what's generated. So boom, that is it. Effective time management, maximizing productivity and balancing priorities. Understanding time, importance of time, identifying time wasting, with images and icons, step by step. This starts you up, and then you can continue. If you give more context, it will even be more comprehensive. You know, this is just a bit, and this uses Llama. Llama. I use Llama as my own model that I use for it. I wanted to use Llama 4, the latest one, because this was originally running on Llama 3. But unfortunately, the resources I have does not have the storage available, because I wanted to show the capability of Llama 4. The idea there is that if we replace the model that is doing this work, if we replace it with a more performant model, we would get even a better result. But then the storage I have, it's not up to, cannot. I got to a point, then there was no storage. I have to remove all the Llama 4 and then roll back to Llama 3 for this session. I wanted us to show this thing. So with that, to end my session before I hand over to the people from Wema Bank that we are happy to have here. So I want to say that as software engineers, and going back to what our boss, Mark Zuckerberg, mentioned about software engineering job would disappear, is that this part of the world, our posture is not good at all. Our posture is always consumer posture, and this goes in line with what Mr. Shams was also trying to say. Our posture is we are waiting for people to outside the world to do something, and we'll use it. We are waiting for the next AI advancement, and then we are waiting to use it. If we continue to do that, we'll be less relevant in the next couple of years in the tech space. So, and of course, we should also not focus on trying to build models. One, we don't have resources for it, and second is it really, do we even have a chance if we want to try to build model? Who are you competing with? You don't have resources that they get. So if you look at the early 90s, what we have was we have some operating system that were built, but now everyone coming up is not trying to build operating system. They're trying to make use of the operating system to do bigger stuff, and then that's why we have a whole lot of softwares and all of those things that came up, riding down the operating system that they have. So, and then when we came along the line, it was already too late. So what we were doing in software engineering was catch-up games, listen to instruction, whatever is being said, anywhere, maybe from America or from whichever community, and then we follow suit. A framework will be released, and then we use it like that. But from 2020 and above, this AI is happening in our own face, in our own time, and it will be disastrous. We will regret it if we do not participate actively. It's a huge opportunity, because this happens in our time. It's pretty much like early 90s of people would, when they make statement, they say it happens where they are happy that, the .com boom happened in their time, and then some of them make fortune. AI boom is happening in our time. How we use it, will determine what we're going to be saying in the next 10 years. So there's a lot of problem to be solved. The ones that we have solved before were solved the wrong way because the resources were not available. So we have to also revisit. So it's a huge opportunity. And some of the job that Mr. Chams and Co are doing will write AIs to take them. Thank you very much, guys.
Thank you, Mr. Kenny.